So welcome to Arzell's OC ILB Friday, where today we're going to talk about low voltage diagnostic. If you have any questions, please feel free to type them in the chat box. If I don't forcibly mute microphones, so if you have a microphone, you can go ahead and ask your question. But if there is background noise, please keep it silenced until you need to ask your questions. But we are here for you. We're committed to offering innovative zoning solutions. We want to make sure we have a strong partnership with our contractors, and part of that is offering a lifetime parts warranty, so there's peace of mind to your customer. Products probably made here in the US, but also tech support that's very responsive and available to you 7 days a week, 8 a.m. to 9 p.m. Eastern time. And we do pick up on weekends, we pick up on holidays if necessary. So we have a strong customer service oriented business here at Arzell Zoning, and we want to make sure that you are getting the best support that you're going to have from any company in the industry. We are proudly made in the US though. We have a lifetime parts warranty, and we'll talk about that at the end of the presentation. But with that lifetime parts warranty, it really provides that peace of mind for your customer because they're getting a product that we're willing to stand behind, and we're so confident in the reliability of it that we offer that lifetime parts warranty. We're also confident in the comfort that it's going to make for your customer. So as long as you're willing to stand behind your design expertise and your labor, we're willing to stand behind our product. And if you do have design application questions, make sure you reach out to us. We'll help you provide clarity. But what it really ultimately comes down to is ensuring that you make the necessary corrections to ductwork in the home if it's inadequate. And we do have additional presentations that focus on duct design to give you a really big overview of how that ductwork needs to be designed to work appropriately with zoning. So that is available. If it's something you're interested in, reach out to us, tech support at arzellzoning.com. Again, that's tech support at arzellzoning.com. You can also use the contact us form on our website, www.arzellzoning.com. Just click on the, excuse me, allergies are just driving me nuts today. But click on the contact us form on our website, www.arzellzoning.com, and you can use that to request a webinar that will fit your schedule. And we can schedule those Monday through Friday, depending upon the length of the webinar. Some of them need to start by 1 o'clock because we do try to have them wrapped up by 4 at the latest. That way we can take care of those questions from technicians that like to call in at the last minute of the day. And then the earliest we try to start webinars is 9 o'clock. That gives us an hour to get things set up in the office, take care of those questions from technicians that waited to call us first thing in the morning. So we try to have that last hour of the day and that first hour of the morning set apart for the technicians that either wait to call us or aren't on the job site and want to give us a call first thing in the morning to find out what they were looking at the night prior. But if you need anything, let us know. If you want a custom webinar, typically 9 a.m. to try to finish up by 4 p.m. Eastern time, Monday through Friday. But today we're going to talk about low voltage, because low voltage seems to be a part of our industry that technicians really have a hard time grasping. When we look at our low voltage, once we break it down, it's actually pretty simple, but it's looking at this huge package and then trying to understand how the individual components work. And everything is really coming down to relays, contactors, electrically controlled switches that allow the flow of electricity, and that flow of electricity controls different components in the system. So what we're going to talk about is how we can effectively diagnose low voltage circuits today. Then we're going to see some different ways that those controls go together and provide us with the operation that we have on our HVAC equipment. But relays make the world move. They're in everything that we do, from our cell phones, our zoning panel, our thermostats, the control boards on our furnace, even those big relay stations that make sure that there's power flowing to everything in our home. It all comes down to relays, and relays provide control of the electricity, control of the current, so that we can ensure that the power is going where we need it to go. They take many different shapes and forms. Some of the ones on here were more common in the HVAC industry, so we're a lot more familiar with them. That one in the lower right corner, that's very common for truck stock to have one of those for humidifiers. The brown one there on the right side, it's not quite as popular today, but a fan center relay for a boiler system or a really old furnace that didn't have the control boards that we have today. It was a relay that plugged into the fan center socket, and that's what gave us our control of the HVAC equipment. So relays are in every part of our industry, and they really haven't changed as far as operation goes. They've just changed in appearance. But a relay is an electrical device that incorporates an electromagnet activating a switching signal that allows the path of electricity to flow. So it provides isolation, it provides control. Those are pretty basic things, but do you have any questions? Before we dig into it, do you have any questions? All right, well then a question for me. What's the difference between a contactor and a relay? As far as the HVAC industry goes, as far as what we work with on an everyday basis with our furnace, air conditioner, our zoning panel, what's the difference between a contactor and a relay? So for what we do in the HVAC industry, the only difference really between a contactor and a relay is the amount of current it's designed to handle. Yep, you got that, Robert. Good. So the contactor is typically designed for greater than 10 amps. The relay is typically designed for less than 10 amps. So when we're looking at the contactor and relay, the difference is really just on the amount of current the device is designed to handle. We got a lot of different types of relays in the industry, but the ones that we're most familiar with in the residential light commercial are the SPST and the SPDT, single purpose, single throw, or single purpose dual throw. And more commonly, that relay on your truck is probably going to be a SPDT, a single purpose dual throw. So that coil controls a single set of contacts. Now you might have the DPDT. That's not quite as common. That usually we're going to run into those more with the industrial controls. But you have your coil. Your coil controls a single lever that bounces back and forth with a spring keeping it at the B side of things, and then you energize it and the magnet pulls it towards the A side of things. So on the SPDT, we have a normally open contact, which is A, and we have a normally closed contact, which is B, so NO and C. Relays from a cutaway, you can see that there's an armature with a spring. That spring wants to hold it in the normally closed position. However, once you provide a current to the coil, the magnet in the coil is stronger than the spring. And when we do that, it then pushes those contacts closed. So that's all we're really doing. We're using one input current to control a different output, and that provides us with isolation. So I've kind of answered this one already. What are we using relays for in the HVAC industry? And the thing that we use relays for is control and or isolation. So the control side of things allows us to have multiple things happen, multiple events, multiple conditions. Then as those conditions are fulfilled, the equipment's allowed to continue operating. On the isolation side of things, you have a humidifier or the RZL panel. Perfect example. The RZL panel has its own transformer. The transformer in the RZL panel powers all your thermostats. However, your furnace has its own transformer as well. We cannot tie those two transformers together, so we have a bank of relays on the RZL board that provide you your isolation. So your HVAC outputs on the RZL panel are dry contacts. We'll talk about that a little bit later, but that is your isolation. It separates out the transformer that powers the panel from the transformer that powers your furnace, because we need that additional power for the thermostats themselves. If you tried to have, let's say, 4 thermostats on your furnace transformer and then power the zoning board with that as well, you'd burn out your furnace transformer before too long. It's just not designed for that current. So sometimes we need multiple transformers to provide additional energy, additional load rating. And that's where the isolation comes into play, because we don't want to tie 2 transformers together. There is a proper way to do that. I'm not going to get into it with this PowerPoint, but the easier way to do it for technicians that are less familiar with phasing transformers is to use isolation relays, and those isolation relays allow you all that same control. So there is a way to tie 2 transformers together. We're not going to get into that, but today we're just going to talk about how the relays provide you that isolation to protect those 2 transformers between the opposing pieces of equipment and give you the operation and control that you need. But relays in action. We've got 2 transformers in this instance. One transformer is energized, which then energizes the coil in the relay when we close a switch. So in this case there on the left side, we had that switch. We close that switch or we open that switch. And as we open and close that switch, the relay opens and closes its contact. Now the purpose in this case would be, I have we'll say the left side of that relay is a 24 volt circuit. The right side of it is 120 volt control. So I have 120 volts flowing through my light bulb. I have 24 volts as my control source. So as I open and close that switch, I open and close the pathway for that voltage to power my light. In our building here at RZL, we actually have a lot of low voltage light switches. That was a common thing in some commercial buildings long time ago. Not so much today, but it used to be that way, so that if somebody were to damage the switch, there wasn't a dangerous high voltage there. So what they did is they would have a relay panel somewhere in the building, and it can really look confusing when you first see it, but that relay panel switches with these 24 volt switches that are all over the walls in our building. And as you hit the switch, it's a 24 volt switch that then energizes the relay, and that relay allows the lights to come on. So we have a low voltage controlling a high voltage, and that's what relays are doing for us in that instance. All right, any questions on that? Still pretty basic stuff, but it is something that seems to be lacking in the industry. I spend a lot of time in tech calls going over low voltage circuits. Next to damper and pump diagnostic, I think low voltage diagnostic is probably the longest tech calls I take, as I walk people through testing voltages, testing resistance, and diagnosing low voltage circuits. And once we break it down, it's actually pretty simple. But are there any questions so far? All right, well, what is the best way to test a relay? What's the best way to test the contacts on a relay? Ohm meter, resistance. The best way to test the contacts on a relay are to test your ohms. If I have a set of open contacts, what am I going to read? Right. We'll read infinity. We'll read high resistance. We'll read OL, or possibly that little infinity symbol. And that indicates an open set of contacts. If I have a closed set of contacts, a lot of technicians listen for that beep, beep, beep on their meter, but that toning doesn't indicate the quality of contacts. So if I'm going to ohm it out, what am I looking for to say that that's a good set of contacts? Zero would be perfect. However, in an imperfect industry, we're actually looking for anything less than 1 ohm of resistance. So if it's less than 1 ohm of resistance, we know that there's not significant impedance. So that's as close to, probably the closest I have ever seen to zero is a 0.02. And that's essentially just touching my meter probes together. So there is some resistance to our meters themselves, not significant. There is some resistance to everything. However, we're looking for less than 1 ohm of resistance, and that indicates that we have a good contact. So when we're testing for resistance, we want to look and see if we have less than 1 ohm of resistance. If we have that, we know we have a good contact. So if we have an issue with our furnace not working and we've tested our resistance on a specific circuit, we read less than 1 ohm, we know that our problem is now somewhere else because that contact is proven. It's verified good. So I don't think there's going to be too many questions with that. But as far as technicians that might be watching this recording later on, let us know if we can do anything to help. Work with your local distributors and see about setting up a time where I can come out. We are starting to get back to where I can travel again. And with that starting to become a thing, I'd love to get out of the office sometime, come meet people and provide trainings in your local area. We just ask that your distributors can try to organize at least 3 different classes for us. And if they can do that, I can travel out and we can provide classes for the local contractors in your area and provide classes for you. And usually the classes don't go all day with the distributors. So during the off time, I like to travel with one of their reps and meet and greet with the contractors and come out, see your offices, talk to you and get to know you a little bit better as well. But if sometimes we can't always test for ohms. So in those cases, we need to test for voltage. Now when I'm testing for voltage, my coil, if it's reading 0, indicates that it's not engaging my relay. So if I test my coil and I have 0 volts across my coil on that relay, I'll know that the control source is not calling for that relay to operate. If I read 24 volts on that coil, then I know that that coil or that relay is supposed to be energized. And when I know it's energized, I know that those terminals are going to test differently. So if I have that single purpose dual throw, or I have that dual purpose dual throw, my common source is going to be labeled. And then from the normally open side, if I'm energized, I'm going to read 0. And we'll see that right here. So if I have an open contact, I'm going to read 24 volts. And the reason I read 24 volts on the switch side, if I have an open contact, is because it's broken. One of those acts as the path to ground. The other one acts as my hot source. So if my switch is open, I'm going to read 24 volts across it. Now, I want to be careful there because I have to also verify that I've actually got 24 volts to there. So if I read 0 volts, that doesn't necessarily mean that my switch isn't closed. I want to verify that I've actually got 24 volts going to that set of contacts. So the reason I like to use the resistance, which we talked about earlier, is because the resistance will tell me definitively whether or not that contact is closed. If I'm reading voltage, I need to test a couple different locations just to verify that there is actually voltage present. And if I can verify that there is voltage present, then a reading of 0 would tell me my contacts are closed, but a reading of 24 would tell me my contacts are open. So if my contact is open, I'm going to see 24. If it's closed, I'm going to read 0. But if I read 0, as I just mentioned, I need to test another point to verify I actually have 24 volts feeding into that contact. Because if I don't have voltage feeding up to that circuit, my voltage test isn't going to really tell me anything, but my resistance check would, which is why I like resistance over voltage. So if you are using voltage, make sure you test a couple different points, verify that there is actually voltage getting to that contact point. And once you verify that there is voltage getting to that contact point, a reading of 24 indicates it's open. Of course, if you read 24 volts, you know you've got voltage going there. However, if you read 0, that doesn't indicate that it's opened or closed unless you first verified that you do actually have voltage making it to that set of contacts. So 0 volts may be open, may be closed. You have to test again just to verify that you do have voltage going there. A reading of 24 volts indicates open for certain. So when we start diagnosing our HVAC system, and we're probably going to burn through this faster than the 2 hours, but when we start testing our HVAC system, we always start at our thermostat. Now there's a lot of things that will tell us our thermostat is running, but if things aren't running, our thermostat's the place to start. And technicians, as they become more experienced, will be able to skip some of these steps, but it's good to know the basics. It's really good to go back to the basics, because when we have a compounding problem, we need to be able to know what is or isn't working so that we can diagnose as many of the potential failures as possible. A compounding problem typically means that there's more faults later on, and as we can test around the trouble that we found initially, we can then verify further points of operation that are causing us problems as well. So the place to start is with the thermostat. And the reason I say the place to start is with the thermostat is because you can't always be certain that thermostat you pulled off your truck is good. Now, that's another reason where I like to use the resistance check, because I had a technician once that had a bad thermostat, and when he got out to the customer's home, he rightly diagnosed it as a bad thermostat. However, he replaced the thermostat and things still weren't working. So he went to the RZL zoning panel and checked things there, and it was in the RZL zoning panel if he jumpered around the thermostat worked. So he put his second thermostat on there, figuring he had a bad one off his truck. But still, that one didn't work either. So he finally called us at tech support, and we had him do the same testing he'd already done with the RZL panel, jumpering out the calls at the panel directly. Everything responded. And then I had him test the resistance on his thermostat directly. And sure enough, the heating call, even though the thermostat said it was calling for heat, that W tested open. So he had a second bad thermostat on his truck. He went and got another one off his truck. And before he even put it on the wall, I had him test that W contact and it was open, even though the thermostat indicated it was calling for heat. So really, really bad luck in that case where he pulled 3 bad thermostats off his truck. He went to his distributor and then he started testing the thermostats off their shelf directly. The first one tested open, the second one tested closed. So he took what I gave him with the resistance checking, and then he went to his distributor, and before he purchased the thermostat, he tested it directly in front of him, and he found one bad, he found the other one good. So he took the good one back to the job, put it on, everything was working great. But those were bad thermostats. The manufacturer at the time for those thermostats apparently had a bad run, and he had some exceptionally bad luck in getting a whole bunch of the bad ones from that run. But he got all his warranty on those thermostats through the manufacturer that did the thermostats. He found a good thermostat at his distributor by doing a resistance check right then and there. So he was no longer guessing that the thermostat he got off his truck was good. He had already proven it before he purchased it that the thermostat was good. He went back, put it on, everything worked. So the thermostat is that starting point for all our controls. And just because the thermostat's calling for heating, just because it's calling for cooling, doesn't mean it's actually calling. And that's where we need to start our testing to verify that the thermostat is good. So in this example, it's pretty basic. We just have our RWYG O/B in common, and I have it drawn out with the relays for open. So as we start calling for things, we're going to see those relays change. So pay attention to the switches. I have a switch that's closed. What does this call if I have a conventional system? Heating. It is a call for heating. How about now? What's this call? This is a cooling call. Correct. This one's pretty simple. Fan call. The G contact is closed. But now we have a heat pump. There's something with the RSL panels that determines what call this is from the thermostat. So looking at that with a heat pump system, thinking specifically RSL panels, what is this call? All right, so something to keep in mind with the RSL panel, from the thermostat, doesn't matter what RSL panel you are using, your reversing valve is always energized on a call for cooling from the thermostat itself. So when I have a thermostat, I have a heat pump system. If my O terminal from the thermostat is energized, that has to be a cooling call. Now, even if you have a piece of equipment where the reversing valve is energized in heating, you got ream root or something like that. Even though that specific piece of equipment requires a reversing valve energized in heating, from the thermostat, the RSL panel always has the reversing valve energized on a call for cooling. And then through the panel itself, we control your reversing valve function to your equipment. So if you have the air boss or the MPS panel, the O terminal and the B terminal on your HVAC outputs are separated. So if you have the MPS or the air boss and you have a piece of equipment that energizes in heating, such as the ream rood, then your reversing valve wire from that equipment hooks up at the B terminal, B as in boy. However, the thermostat still has to energize that reversing valve on a call for cooling. So when I look at this thermostat call and I think about the RZL panel, the O/B terminal is closed, that has to be a call for cooling from the thermostat, because the RZL panel is what controls your reversing valve. So then when I look at the reverse of that, my reversing valve terminal is open now. I know that's a call for heat. So if you have the air boss or the MPS, there's a series of LEDs that will tell you what terminals are energized. So each of the zone terminal strips for the air boss have 2 reds, 2 yellows, a green, and a yellow. If that bottom yellow light is lit, that's your reversing valve. That is a call for cooling. If that bottom yellow light is not lit, then a call for compressor and fan is a heating call in heat pump mode. So when it comes to heat pumps, the RZL system always from the thermostat energizes the reversing valve, and cooling from the panel itself is where you're going to determine your equipment, because the panel controls your reversing valve, not the thermostats. Does that make sense, Robert? Yeah, I throw those ones in there as trick questions because it creates conversation with people when I'm out there live in person. You'll have some people that answer heating, some people that answer cooling, and they start talking about the difference between the brands. But when I start thinking about the RZL system, it is very specific. It's always energized in cooling. Our panel is what controls it. So your brand of equipment, when the thermostat's calling, is completely irrelevant when we look at it with the RZL system. So they're gotcha questions. I put them in there specifically for conversation. So now that we've finished with the thermostats, we need to start looking at the equipment. So on a basic call for heat, my thermostat calls for R and W, the contact closes. And then from the control board on the furnace, it'll energize my vent motor. I have a 120 volt source that powers my furnace. I have my control board, which is 24 volt to my thermostat. My thermostat then controls my contacts. So on a call for heat, if I've got 120 volts at my furnace, and this does need to be verified, I take calls on my furnace isn't operating, but my zoning panel is, and it turns out that somebody flipped the switch off at the furnace, so there was no voltage at the furnace itself. But because the RZL panel has its own transformer, they didn't put 2 and 2 together. So we need to verify that the furnace actually has power. We need to verify that the furnace transformer is actually working when we look at it with the RZL system, because the RZL uses its own transformer, and that's what powers the thermostats. So just because your thermostats are powered doesn't mean that your furnace is powered when we look at it from the RZL side. So on a call for heat, I close W. That then starts my vent motor. My vent motor operating closes my draft switch. So that proves that my vent motor is running now. With my draft switch closed, I'm looking to make sure that my limit switch is closed. And while those happen simultaneously, this is kind of a sequence of operations, but a lot of these things happen at the exact same time. The check is happening at the exact same time. And if any one of them fails, my heat does not run. So from my call for heat, my vent motor starts. My vent motor proves my draft switch. My control board also proves my limit. If my limit is open, it's not going to allow the gas valve to start. So if my limit switch is closed, my draft switch is proven closed, my gas valve is then energized. And then there's another circuit, the flame circuit, the flame proving circuit. We call it flame rectification. That determines that there's a proven flame. If there's a proven flame, a fan timer starts to give that heat exchanger a chance to warm up. Once that timer is complete, my blower activation relay starts and my blower kicks on. So when we start looking at it, our thermostat initiated the call for heat, and then we can see the dominoes that fall into place to actually make that heat run. And very basic operation with this, two-stage furnaces change things up, variable speed motors change things up in the final part of it. However, that doesn't change the very basics of it, because there's a draft switch that has to close to prove my vent motor's running. There's a limit switch that has to be closed to allow my gas valve to start. There's a flame proving circuit that has to prove that my gas valve is actually working in order for it to keep energized. And then once that's proven, I have a timer, my blower starts, and I get heat going to my home. So when we start taking it back to the very basics, it makes the diagnosis a lot easier, because as we work our way through the process, we're able to find those failures and diagnose them effectively for our customers. So step one, we started our thermostat. From there, we prove it at our furnace. From our furnace, we make sure our vent motor starts, make sure our draft switch, our limit switch, make sure that those are closed. If those are closed, our gas valve will start. If our gas valve is proven to flame circuit, it starts our timer, and then our blower starts, and we have heat. And the steps are pretty much identical from one furnace to the next. It's just different configurations. So while it may look different because the furnace is set up differently, things are in different locations, it all operates exactly the same. We start with the thermostat. From the thermostat, we move to the furnace. From the furnace, we move to the individual components to see which ones are starting, which ones are not. And as we knock those dominoes down, we can prove what is or isn't working, and we can work our way through the system with relative ease once we go back to the basics. On a cooling call though, and this goes way back. It's been like this for a very long time. A cooling call always has to have a fan call with it, because your cooling call, the Y, really only controls your compressor, and it determines whether or not the furnace needs to run a high speed or a low speed blower, but it does not determine that the blower actually operates. Your G call still needs to be there. And with the RSL panel, if the G call is not there, the panel will view it as an illegal call. So if you are missing G, you don't have a valid call for cooling. A valid call for cooling is Y and G. So that basic cooling operation, our G call comes in, and that starts our blower. Our Y call comes in, and that starts our blower on high speed. Now that Y call then goes to the outdoor unit. If it's a really basic outdoor unit, it may or may not have high pressure and low pressure switches. This is a call I get often enough, and it's going to start up here pretty soon because spring is here. People are starting their preventative maintenance checks for cooling, but they'll be at the RSL panel and they'll say that it looks like it's calling, but my outdoor unit's not working. And then they go to their outdoor unit, and while everything inside the voltage tests out great, there's no low voltage to control that contactor outside. And it almost always comes back to a high pressure or a low pressure switch is tripped. So that's why I have them drawn into here. Or potentially a mouse chewed on a wire, broke it. The dog chewed on a low voltage wire. That's a pretty common one as well. But it's a break in the wire somewhere. And if it's not a mouse or a dog or a cat or somebody with their weed trimmer getting too close to the air conditioner, it's probably the high pressure or the low pressure switch. So those have to be closed, and when they're closed, they allow the contactor to start. The contactor starts, brings on the fan and compressor at the same time. And there's not a lot to it. You verify that your low voltage source is doing what it needs to do. And if you go outside and you see the contactor pulled in, you know your low voltage source is doing what it needs to do. If your stuff's not running, it's either a capacitor or there's no high voltage power. If it is running and they have a problem with cooling, you got something else you got to look at. But if your low voltage source, everything starts at the thermostat. So we go right back to the thermostat. Step one, verify your thermostat. Check your voltages, verify. Check your resistance if there's no voltage there. If there's no voltage there, that'll be a pretty obvious one in this case. But if you have voltage and things still aren't working, check your resistance because that'll prove those contacts for you. So step one, we start at the thermostat. Our blower should kick on right away with the call for cooling, so that one's pretty easy to verify. The blower kicks on, we're good to go. We can move to the outdoor unit. Do we have voltage at the coil on that contactor? If we don't, then we need to back up. We need to take a look at the high pressure switch, the low pressure switch. We need to take a look and see if there's a break in that low voltage line. So if we have everything operating inside, our blower kicks on right away, it kicks on at high speed. We know that the furnace is working. We know that the thermostat's working. We move to the outdoor unit. We're missing our voltage there. We have to back up because there's a break in that line somewhere. Now it might be a high pressure switch, might be a low pressure switch, might be a mouse, a weed whacker, a dog, a cat, some kind of animal chewing on the lines. We have to back up and take a look at that. But if it's there, then our compressor and our fan will start, as long as we got the high voltage present as well. A heat pump though adds an additional layer because there's a defrost board outside. And once upon a time, the defrost board would throw me for a loop, but then as I became more and more familiar with how low voltage circuits worked, the defrost board really isn't any big deal because it's all about a low voltage source controlling a high voltage source. So it's where's your power at? Once you've verified your power, you know that that part of the system is working. If it's not, then you found your problem. So you start at the beginning, start at your thermostats. From the thermostats, we move to the equipment. From the equipment, it should be pretty obvious that our blower starts. And then once we've proven that, we can now move to the outdoor unit, to the defrost board. And at the defrost board, we're going to determine, do we have our voltage out there? If we do, we need to see what's running. Did our contactor close? If it didn't, then we probably have a high pressure or a low pressure switch that's going to be open. But there's really a lot to take a look at with the defrost board, but it's still all exactly the same. It is your relays, it is contacts, it is a low voltage controlling a high voltage source. And as we start testing for the voltage, we can start to knock things down to see where the problem's at. If our compressor and our outdoor fan or our condensing fan motor don't start, it might be a high pressure switch, it might be a low pressure switch that's open. Once we verify those switches, then we can move on to figuring out where the problem's at. So the defrost board applies some logic to it. That logic is going to determine whether we're running in heating or cooling based on what's coming into it. So from the RZL panel, The thermostats are always energized and cooling on the reversing valve, but we'll control that reversing valve operation based on your brand of equipment through the panel itself. In this case, we're just going to say it's energized and cooling. So as we start testing our voltages, we can start to see what's happening. If our motors aren't starting and stopping, it's probably an issue with the high pressure or low pressure switch. Might be a problem with the capacitor. Those are things to look at, but it all comes down to verifying our voltage, verifying our resistance, checking to make sure that the control source is doing what it needs to do. And then if our reversing valve is energized or if it's de-energized, determines whether or not we have a call for heating or whether or not we have a call for cooling. So are there any questions when it comes to the basics of operation with equipment, with the relays, the contactors, the control voltages? Any questions I can try to clarify there? If not, I'm gonna take a short break, use the restroom. There's not a whole lot left to it, but we're gonna talk about how the zoning panel ties into it now. All right, well, it is 9:56 on my clock right now. I'll be back in my seat. We'll say 10:05. It gives me a chance to use the restroom, grab another water. But a lot of this is really just trying to take technicians back to the basics, because that's next to damper and pump diagnostic with Arzell. The basics are really where I spend the most amount of time on tech calls, and it's really all about proving where the voltage is at, proving whether or not a contact is or isn't working. And once we understand that, once we're able to go back, we can get proven operation. We can know what is or isn't working with certainty, and we can let our diagnosis go from there. So rather than guessing at potentials, we can test out and verify potentials. And that helps us all be better as a whole to meet the needs of our customers and to show them that we are the professionals and we're the ones that they should trust with their homes. So short break. I'll be back in my seat. My clock says 9:57 right now, so I'll be back in my seat at 10:05. All right, I am back. Are there any questions before we move on? All right, well, if there are no questions. So now that we've seen the equipment, now that we've seen how the thermostats operate, we need to add zoning to it. When we look at zoning, the zoning system takes multiple thermostats, applies a set of rules, and gives you your outputs. When we have the RZL Heat Pump Pro, all it needs is a W input, and it'll provide you with up to 4 stages of heat, 2 stages of cooling on the outputs based on your configuration. So if you have an all-electric system, a heat pump with 2-stage electric backup heat, the Heat Pump Pro will provide you with 4 stages of heat, starting with first and second stage condenser, moving to first and second stage of backup heat if necessary, based on your leaving air temperature. So we can have thermostats all calling for different things: fan calls, heating calls, cooling calls. The RZL panel applies a set of rules and determines what we're going to send to our equipment so that we aren't damaging our equipment with conflicting calls. When we look at the RZL Heat Pump Pro, there's that line that says out. That line that says out tells you exactly what's going to your equipment. So for this one, I have it showing what you would typically see for an all-electric application with all 4 stages calling. We see W1, W2, Y1, Y2. So that's compressor, first and second stage, Y1, Y2, as well as first and second stage of our backup heat. We can see our blower running at high speed with air handler Y1, Y2, and we have that G call going to the equipment for the fan operation. We can see that it says zones 1 and zone 2 are being served. So that's in the lower left-hand corner of the screen. It says zones 1, zone 2, or 1, 2. It's not 12, that's zone 1 and zone 2. So we can see that we have those 2 zones being serviced. Their weight adds up to 100%. And one of the things with the RZL Heat Pump Pro is that your weight percentage does not have to total out to 100%. It can be less than 100. It can be greater than 100. If you want to know how the zone weighting works, let us know. We do have a training for the zone weighting specifically to go over the Heat Pump Pro settings and give you more in-depth information with that. But with the zoning panel, we can have thermostats calling for opposing things. The zoning panel provides the rules that prevent opposing or conflicting calls from going to our equipment, and that allows everything to work together nicely. But we have our thermostats. Now, when we look at the zone panel, while we might not have all those same safety switches that you're going to have with your furnace from like the draft proving switch and all that, those are all part of your furnace. But when we're diagnosing it, as far as the voltage is concerned, our thermostats are our thermostat, but our HVAC inputs, the zone terminal connections in the RZL board, would be our equipment. In relationship to the thermostats, those zone connections would be our equipment. And then when we look at the furnace side of things, the HVAC outputs are a thermostat in relationship to the furnace. So your furnace has all its safety switches. And the RZL panel does have the Heat Pump Pro and the AirBoss do have a high temperature and a low temperature protection built into them. So that's where we look at that line that says out. If it is listed on that output line, it is energized going to your furnace. We look at it where it says zones. That tells us exactly what zones are being serviced. So when we look at this, If we don't see our thermostat calling listed in the zone box, that thermostat's not receiving its call. And we have additional classes to go through the Heat Pump Pro as far as what we would call an illegal call. There's also an instructional video for illegal calls on our website. So if you go to our website, rzlzoning.com, if you don't yet have an account, click on contractor sign up. If you do, there's a tab that says technical videos, and in there is HPP illegal calls. And we walk you through the various illegal calls that you might see with the Heat Pump Pro and how you can get around testing to verify that the panel itself is working correctly and leave you with a definitive it's the thermostat or it's the thermostat wire. So if you need an instructional video on that, it is available in the technical video section on the contractor portal. If you want to have a PowerPoint set up like we're doing today, let us know. Use the contact us form at rzlzoning.com or contact us, tech support at rzlzoning.com. Jason or I will get a webinar set up with you and we can go through Heat Pump Pro diagnostics specifically. So when we start looking at how things are calling, I'm not sure if my slide reset or if it doubled up. We start at our thermostats, step 1. We verify that our thermostats are calling. From there, we move to the zone panel itself. We verify that the zone panel is receiving those calls. And then once we verify the zone panel is receiving the calls, we can verify the HVAC outputs. And while we don't necessarily have to go to each individual device to test it with our meter, we can turn everything on how we want it to work. And then we can go to the RZL panel. The Heat Pump Pro has the screens that walk you right through your diagnostic. Tells you exactly what thermostats are calling, tells you exactly what's being outputted for. So if we start there, we get a high overview of what's happening. And then we can know that this, and this are working. But if we don't see it happening the way that we think it should, or the way that it's supposed to be, now we can focus our diagnosis there. So with the Heat Pump Pro, we can view our thermostats individually, and we can focus on that specific thermostat, that specific set of zone connections, because that's our thermostat and our equipment. And we can see where our problem's at on that specific zone. So it might be broken thermostat wire, it might be a bad thermostat. Rather than trying to diagnose all 4 zones in our equipment at the exact same time, we break it down into individual zones. Each zone has a thermostat. Each connection inside the board, zone 1, zone 2, zone 3, zone 4, is our equipment in relationship to that thermostat. And then the zone panel tells us exactly what it's outputting for. And those outputs are a thermostat in relationship to our equipment. So we don't have to try and diagnose all 4 zones in our equipment at the same time. We can break each zone down individually, and then we can break the equipment down away from the zone thermostats themselves. So rather than turning a thermostat on saying the equipment's not working and then instantly condemning the RZL board, we need to take a look and verify that the thermostat's doing what it says it's doing, and then see what the panel says it's doing and verify that as well. The AirBoss is very similar to the Heat Pump Pro. We can have heating calls come in. We can have a cooling call come in. We can have our fan call. Our thermostats are just that. They're a thermostat. From the thermostats, we move to the panel. Each zone connection is our equipment in relationship to that individual thermostat. And then from there, our HVAC outputs are the thermostat in relationship to our equipment. So we start at step 1. We turn our thermostats on. Once our thermostats are on, we then go verify that the board is receiving that call. If the board is not receiving that call, then it's either a broken thermostat wire or it's a bad thermostat. So we would then have to look and see why is my thermostat, or why is my board not receiving that call? And that would be voltage testing up at the thermostat itself directly. Do we have the voltage up at the thermostat where it needs to be at? If I pull my head off the wall, my thermostat head off the wall, do I have voltage between R and W? Do I have it between R and Y, R and G, R and O, R and C? If I have voltage between R in each of those terminals, then I need to look and make sure that none of my connections, W, Y, G, O, are potentially shorted together. But if those check out good, there's no shorts between W, Y, G, O, and I have voltage between R and each of those wires, then I know my thermostat cable's good. My problem has to be with my thermostat itself. But if I don't have a good voltage check from those wires, if I don't have a good resistance check to tell me that I don't have anything shorted out, then I know that I have a problem with my thermostat wire and I can proceed from there. Now, the RZL panel is really simple to work around just to verify operation, because if I take a jumper wire and I jumper R and W1, that's a call for heat, or with the Heat Pump Pro, it's R and W. If the panel receives that call and everything works, yes. So on this image, there are 2 thermostats in heating, 1 thermostat in cooling, 1 thermostat in fan. That's to show that you can have thermostats with dissimilar calls, but the panel plays the coordinator. And as a coordinator, it determines what takes priority, heating, cooling, or fan. Well, in this case, fan, doesn't matter what panel of ours you have, fan is always the least priority. So we pick between heating or cooling based on your operation. So if your thermostat is calling for heat, the other thermostat's calling for cooling, you can set a priority between heating cooling calls and it will serve that priority. With the Heat Pump Pro, and we would talk about it more in depth with the Setup Wizard, you have heating priority, cooling priority, zone weight priority, or auto. With the AirBoss, you have auto, heating, or cooling because there's no zone weight. But automatic is first come, first serve. So if my heating call comes in first, it's served for 20 minutes and then it'll switch to the opposing call. But the panel will never output for heating and cooling at the same time. It will only ever output for one or the other, opening or closing the zone dampers appropriately based on whether it's serving that heating or cooling call. Did I confuse you there, or was that understandable enough? All right, so with the Heat Pump Pro, there's individual zone screens that tell you exactly what's being received from the thermostat. With the AirBoss, there's an LED indicator for each of the zone connections. There's LED indicator on the HVAC outputs. So instead of the LCD screen that you have with the Heat Pump Pro, the AirBoss LEDs will tell you what it's doing. So looking at your zone connections, top to bottom, it's red, red, yellow, yellow, green, yellow. That tells you W1, W2, Y1, Y2, G, and O. And then across the top where the HVAC outputs are, it's red, red, yellow, yellow, green, yellow. That's W1, W2, Y1, Y2, G or green, and reversing valve O, yellow. So we start there. We verify that each thermostat's calling. We verify that the panel's receiving that call, and then we verify our outputs. So we start at the thermostat moving to the equipment, thermostat to zone panel connection. And then from there, we started another thermostat, HVAC outputs, and we move to our equipment. So once we start verifying those calls, we can determine what is or isn't working appropriately. And then we can break that down into something that's more bite-sized, more understandable. So instead of trying to wrap our head around 4 thermostats, we can focus on one thermostat at a time, verify it's doing what it says it's doing, verify the board is receiving it, and then we can move to the next thermostat. And then once we verify that one, we move to the next. Once that's verified, we move to the next. And once those are verified, we now move to our HVAC outputs, which are a thermostat in relationship to the equipment. The panel is going to have several diagnostic lights on it. It might be first and second stage heating, LAT, might be compressor lockouts. So the panel does have indicators to tell you that it's got something disabled. There's reasons for it. And if you're confused when you're looking at it in the field, reach out to us, tech support at rzlzoning.com. So G, Y, and W, if you notice, so your question is zone 1 thermostat has closed, G, Y, W, is it in heating or cooling mode? But if you notice at zone 3, it has Y, G, and O closed. So if you remember back to the thermostats, O is always a call for cooling when you have a heat pump. WYG closed is a call for heat pump with auxiliary heat. So this would actually be an all electric application. You have your heat pump, your thermostats are calling for the compressor, and then you have one stage of electric backup heat, W, and your thermostat determines it needed to call for the auxiliary heat. Now the AirBoss, if you want the best control of multi-stage equipment, you need to use 2-stage thermostats. It does have built-in board timers. Not as huge a fan of delay timers as I am of letting the thermostat control the staging. The Heat Pump Pro is a little bit different because it controls your staging itself, and it does that with just basic thermostats. However, the AirBoss, your thermostat matches its application. So if you have a heat pump system, use a heat pump thermostat. And in this case, WYG is a call for heat pump with backup heat from the thermostat. YGO is a call for cooling because the O is energized. So with all the RZL panels, you can never energize from the thermostat O and W at the same time. That would be an illegal call. So that O terminal is what determines whether it's heating or cooling. And if it's a heat pump application, O is open, it's a heating call. If it's a heat pump application, O is closed, it's a cooling call. And you can never energize O and W at the same time coming from the thermostat, because the panel will view that as an illegal call. Does that make sense, Robert? All right, so something to keep in mind with RZL, we do custom panels. It's not just basic. With the Heat Pump Pro, the Heat Pump Pro is your staging control. It's your backup source control. It is your dual fuel changeover control, and all of that, which is basic RWGY type thermostats. The AirBoss, your thermostat requires that it meets the application. So if you're using dual fuel with the AirBoss, you've actually got a lot of different options for that. I'd actually recommend calling us at tech support to go over those. I'm not going over it with this PowerPoint itself. With the Heat Pump Pro, extremely simple. Call for Heat W, gives you all your electric control. So 4 stages of heat, 2 stages of cooling, or if you have dual fuel, it gives you that dual fuel changeover based on outdoor air temperature. But the Heat Pump Pro is your universal panel, good for anything single stage conventional all the way up through 2-stage dual fuel. Now there are custom applications where we have an accessory control. We call it a ZVI, a zone valve interface. That ZVI control allows us to add boiler heat with forced air heat very easily. So if I have a customer, they want warm floors. With the RZL system, there are no master thermostats. All thermostats are master. So with the Heat Pump Pro, you can set a zone weight priority. So if you do have one zone that may at times have dissimilar calls to the other zones, you can set the zone weight priority and make that zone a larger weight. However, our panels don't have a master thermostat as far as operation goes. Now the AirBoss does have a switch on it that says master zone. It's also set of contacts, say stat setback. So the question being, do you have a master thermostat? Which one is it? The answer to that is simply there are no master thermostats. The AirBoss allows for a feature called master zone, in which if that is set to on, or if the stat setback terminals are closed, so you have a timing switch. This is more popular for commercial application. When those contacts are closed, Zone 1 thermostat controls everything. Zones 2 through 8 would be ignored with the AirBoss. Zone 1 thermostat calling opens every single damper in the entire system, and it conditions the building as a whole. So what that would be popular for is a commercial application where you just want non-programmable thermostats at zones 2 through 8, the number 8. In zone 1 is programmable so that when you have a timing control, a timing relay at a certain time of day would close, everything would revert to the program built into zone 1, ignoring zones 2 through 8. Every damper would open, the building would maintain based on the zone 1 thermostat program. The Heat Pump Pro does not have that feature. Every thermostat is master. However, if you need to test the system to do, maybe you're doing your startup testing, you don't want the thermostat to be able to, or you don't want your customer to be able to turn off a thermostat and screw up your testing numbers. You want everything to stay open. We go over it a little bit more with zoning specific diagnosis rather than low voltage diagnosis. But on all of our panels, the solenoids, there's a terminal marked plus, and you'll notice that there's multiple wires in those plus terminals. That's common. If you were to disconnect those plus wires, so you pull them out of the terminal, every solenoid is de-energized, and doesn't matter what thermostat's calling, every single damper in the system would remain open. So now if you don't want to run through the house and find every single thermostat, you don't want to worry about your customer over conditioning in one zone and turning that thermostat off on you, you can disable the solenoids by disconnecting the plus wires and then do your checkup, do your startup, get all your test data, and then reconnect those plus wires and the system will go back to normal operation. With the AirBoss, the master zone switch allows you to take zone 1 thermostat, control everything, driving every damper open whenever zone 1 calls, ignoring inputs from zone 2, 3, and 4. But the Heat Pump Pro doesn't have that same feature built into it. Does that answer your question? Okay, so with the ZVI control, we can incorporate hydronics with forced air system. And while it looks to be complicated because you got wires going every which way, it's really not once you break it down. It's just a call for W1, W2. With the Heat Pump Pro being able to control 4 stages of heat with a single stage call for W, that W2 from your thermostats goes to the zoning panel. The W1 from your thermostats goes to the ZVI. So now your thermostats, if you have a hot water heat, your floor heat, W1 from your thermostats brings on the floor heat. W2 from your thermostats, because your thermostat says I need additional heat in this zone, W2 from your thermostat would then bring on the forced air system for that specific zone. And this is a melding of the best of two worlds, because hydronic heat is not good for stat setback. Hydronic heat is really bad if you want to turn your thermostat back at night, because it takes a very long time to reintroduce that heat into the zone, because it starts with convection. It warms objects, not necessarily the air, and then those objects then warm the air as they give off their heat, and that process takes a lot longer than when you forcibly mix the air through a heat exchanger. So if you want to use stat setbacks, but you still want the comfort that boilers provide, because walking on a warm floor, you really can't beat that. You wake up in the morning, your toes touch that, your toes touch the tile floor or something like that. If it's cold, everything in your body likes to clam up, and then it just hurts your joints. If it's warm, everything in your body seems to relax and it's a lot more comfortable. So if you want to mix the best of both worlds, you want that in-floor heating, so you got the nice warm floors, but you also want to be able to set things back, because studies do show we sleep more comfortably at 65 to 68 degrees, but a lot of people like to keep their homes at about 70, 72 degrees. And if you don't want to have that delay time from the stat setback trying to warm your house back up with the boiler, the forced air system provides you that quick recovery, and we can bring those two together in a nice, neat package with the Heat Pump Pro and the ZVI control. So next we're going to go into warranty. Are there any questions I can answer from what we've talked about today? It's really a class that's geared towards taking technicians back to the basics, making them think about the control source for everything that we work on. One voltage controls another voltage, and effectively diagnosing the two. So that's really what this class was meant to do, was to get technicians thinking back to the basics of how we actually heat people's home. And it's all about controlling the voltage, making it go where we want it to go. And that's through relays and contactors and safety switches. So as we test down the line, we can knock off components for being good, bad, and we can work our way down the line from there to get a full system test and know for certain what is or isn't working appropriately. So are there any questions with regard to today's training? All right, well, I know you've been through this one a couple times as far as the warranty process goes, so I'm going to go through it for the sake of the recording, but I do appreciate you attending, Robert. If there's anything you need, please let us know. If you cut out during the warranty, I won't hold it against you, but I'm going to go through it for the sake of the recording. So Arzell has a lifetime parts warranty. It's lifetime parts as long as it's registered within 90 days of installation. Our lifetime parts warranty started January 1st, 2013, and it continues on to present. As long as it's registered within 90 days of installation, it's warranted lifetime to the original homeowner. Prior to that, we had 5-year panel, 10-year dampers. So some dampers from the warranty prior will still be covered up until 2022. After that, any dampers prior to 2013 will be outside of warranty. As long as that system's registered within 90 days of installation, lifetime parts to the original homeowner. So make sure you go on our website with the product serial number, so the panel serial number. Make sure you go to our website, register that to get your customer lifetime warranty. Without registration, there's a 1-year warranty. However, we do offer grace out to 5 years as long as the technician is following our warranty process. And for that, the technician has to call us while they are on the job site, 800-611-8312, to verify the diagnosis with an RSL tech support person, so myself, Jason, Ken. Once we verify that diagnosis, we send repair parts directly to contractors. So 99% of your warranties are going to go directly through RSL. They do not go through your local distributor. And what this does is it allows us to go through what we talked about today, the low voltage diagnostic process, because majority of the time when someone tells us the zone panel's not working, it turns out to be something external to that. And it may be damper and pump diagnosis. We have a video available for that on our contractor portal. So rslzoning.com, contractor sign up, technical videos, damper and pump diagnostic. However, a lot of times it comes back to be electrical in nature, a bad thermostat, a break in the thermostat wire, or something outside of the panel. Once we verify everything from the thermostat to the panel, we verify the HVAC outputs with a resistance test because they're dry contacts. If the equipment's not running, it is now a problem with the equipment itself. So we want to go through these steps of diagnosis to verify, and that's what really allows us to keep offering our lifetime parts warranty, because we weed out the potential for parts replacement. And that's what our warranty process is for. If technicians do not follow our warranty process, warranties may be denied outright. If they go through their local distributor without following the warranty process, we may make an exception, but there's a 20% processing fee on that if we make the exception. And that's usually based on how many times we've warned the contractor in the past that they need to call us while they're on the job site. If we've done that too many times, the warranties will be denied until technicians call us from the job site. If it's a first time offense, we're pretty easy to work with. Second time offense, you're not going to get the processing fee waived. Third time offense, the warranty is going to be denied. So we do keep track of that. We're really easy to work with. We just need technicians to call us while they're on the job site so we can work through some diagnostic, verify the failure, and we send repair parts directly to you. To help the technician, we are available 7 days a week, 8 a.m. to 9 p.m. Eastern time. We pick up on weekends. We pick up on holidays. We're widely available. We're easy to get a hold of. We just need the technicians to call us while they're on the job site so we can continue to maintain our tight quality control process, which allows us to maintain our lifetime parts warranty. And if it is a failure of the RSL, we're not going to argue with you about it. So. Oh, no, we don't take offense to the suggestion, Robert. Making the trainings an hour long. The OCILB Fridays have a range of availability, a range of length. So we've got 2 classes that are 3 hours long. We have 2 classes, maybe 3 that are 2 hours long. But the other ones, the other 5 are an hour long. So we have a range of hours to try and generate interest from 1 hour all the way up to 3 hours. And then we do our webinar Wednesdays. Those are typically about half hour long, just a quick overview. So for those who are interested in the more in-depth classes like today, those are available. For people that are just looking for something really fast, but not really looking to dig into the topic, we do that as well. But all of our warranties require a panel serial number 4 letters, a dash, 7 or 8 numbers. It's on the inside of the panel box, lower left-hand corner for every single one of our panels. We need that so we can look it up and verify warranty. Lots of resources available to you. Just go to our website, click on contractor sign up if you don't yet have an account. If you do have an account, just log in and there's plenty of resources available to you there. If you need additional help, let us know. 800-611-8312. Again, that's 800-611-8312, or reach out to us, tech support at rzlzoning.com. All the webinars are available to you. We do record them and upload them to our contractor portal. So if you want to review them at a later time, you can. We do custom webinars. And as I mentioned just a minute ago, those webinars can be anything from 15 to 30 minutes all the way up to 3 hours. I think the longest webinar I've done is 5 hours. Not a huge fan of doing those. Those ones are much better done face-to-face in person. So webinars are typically going to be somewhere between 15 minutes and 3 hours, depending upon what you're looking for. The Wednesday series is 15 to 30 minutes, so 15 minutes to 30 minutes long. We call that our webinar Wednesday. OCILB Friday, based on what you're looking for, varies from 1 hour to 3 hours, and those are set up to give technicians a quick run through or something that's really going to dig into the topic a bit more advanced and try to get them thinking. But those are available custom times as well. Just let us know, tech support at rzlzoning.com, and we can set a time slot aside for you and go through a web training. Our Comfort College, because of COVID's on hold, but that's why we're doing the OCILB Friday. Our Comfort College was a full day, an entire Friday, 8 hours. We had our Comfort College Plus, which was a day and a half. So that was 4 hours on a Thursday, 8 hours on a Friday. And that went over everything RZL related. So that was something that we were doing, but because of COVID-19, we had to cancel those in-person classes. And I love to travel. I enjoy getting out and meeting with contractors across the states. So we are starting to loosen the restrictions on travel. If you work with your local distributors, we'd be happy to set up classes where we come out and to their branch, to their training facility, and put on a live class for you, getting that back and forth with myself face to face, so we can actually see who's not understanding who. It's a lot easier when our faces are in front of each other and we can read what's not being said. So I do enjoy traveling. I enjoy meeting with people face to face. Work with your distributors to set up some classes, and if we can get at least 3 classes in an area to stretch out over about a 2-3 day period, I'd love to come down and visit people and talk about RZL zoning and HVAC in general. If you need any marketing literature, marketing at rzlzoning.com, marketing at rzlzoning.com, or you can use our contact us form on the website. So www.rzlzoning.com, click on contact us and request your marketing literature. But we are here for you. Let us know how we can help. We want to ensure that you're receiving the best product support in the industry, and that's really what we're here for. So rzlzoning.com, or give us a call, 800-611-8312. Use our contact us form, call our phone number. Tech support's here for you 7 days a week. That includes weekends, that includes holidays, 7 days a week, 8 a.m. to 9 p.m. Eastern time. So are there any questions, anything that I can address? Is there anything I can clarify for you, Robert? All right, well, I thank you for your time. And for those who might be listening to this recording later, let us know how we can help. 800-611-8312.